Bright Tuty. Every student matters.
Let us say we have got a plain top or lattu which had no color on it. So he wanted to color it with his crayons. The top is shaped like a cone surmounted by a hemisphere. So this is a cone and this is surmounted by a hemisphere. The entire top is 5 centimeter in height. So this entire structure this height is 5 centimeter, okay, and the diameter of the top is 3.5. So this will be 3.5 by 2, right. Now if I join this, what I need to calculate, find the area he has to color. So we are talking about this area, this outer area and this outer area, right. So the curved surface area of cone and the curved surface area of the hemisphere has to be calculated. So if I say that the radius is r and slant height is L, so what will be this height here, height of this cone, it will be 5 minus this height, and what is this height, this is 3.5 by 2, right. So if I denote it by h, what is h, it is 5 minus 3.5 by 2, right. So this is equal to 10 minus 3.5, which will give me 6.5 by 2. So this is equal to 3.25, right. So this will be the height of cone, okay. So what will be the slant height of cone, L will be equal to r square plus h square. What is r? R is this radius, which is 3.5 by 2. So L is equal to r square plus h square square root. So it is equal to 3.5 by 2 squared plus h squared 3.25 square square root, right. If you calculate this, this will be around 3.7 centimeter. Okay, I leave the calculation part to you. So this is the slant height of this cone. Now if you need to talk about surface area that has to be painted, surface area to be painted, it is equal to pi RL plus 2 pi r square, where L is 3.7, R is 3.5 by 2. So it is equal to pi 3.5 by 2 into 3.7 plus 2 pi 3.5 by 2 into 3.5 by 2. Okay. Now you can do the calculations. You can write the pi as 22 by 7. 3.5 can be written as 7 by 2. Okay. Or you, if you are comfortable with 3.5, you leave it like that. 2 into 22 by 7 into 3.5 by 2, 3.5 by 2. So this will get cancelled, 2 here, this will give you 2 here, okay. So this is 22 by, this will also give you 11. So 11 by 2 into 3.7 plus this is 2 will get cancelled, 22 into 3.5 by 4, right. So the only the calculation part is left, right. So what we can do is, we can write it as 22 by 2 also. So if I take 22 by 4 as common, inside I will have 3.7 plus 3.5. 11 by 2 can also be considered as 22 by 4. So this is equal to 22 by 4 into, this is 3.7 plus 0.5 will be 4.2 and this will be 7.2, okay, and which will be easily cancelled by 4, 1.8. So now you can do 36, 36, 6, 9, 3. So it is equal to 39.6, and we are talking about area here, so it is centimeter square, right. So this is how you will calculate areas of combinations of solids. There is this another question where we have got a decorative block made of two solids, a cube and a hemisphere mounted on it. The base of the block is cube with edge 5 cm and hemisphere is fixed on the top. It has got diameter 4.2 cm. Find the total surface area. So you need to first of all make the questions flow in your mind, how you will proceed about the question. You need to break these solids and then understand which area the question is talking about. Let us say this is the hemisphere which is mounted on it, right? So when a hemisphere is mounted on it, you need to notice that this area will vanish, right? Let us say I have got a solid and I mount something on it. So the area that is covered by this hemisphere will vanish, right? In this new solid, this is the area that we are concerned about. This area we need to eliminate, okay? Let us say this was the top of the cube. So this circular area is gone now, right? Because we have placed something on it. So this new surface will be the required surface that you have to calculate. So in this question, you have to calculate this surface area and surface area of these faces of the cube, right? And this area. Okay. So now I need to talk about total surface area of the block. Okay. Base of the block is cube with edge 5 cm. So total faces of a cube are, there are 6 faces of a cube, out of which we will talk about this face, let us say later, okay. So 5 faces I need to talk about, plus if I talk about this face now, let us say I calculate the area of complete square, right? Every face of the cube is a square. So area of square minus, I need to subtract this circular area here, okay. If this hemisphere has a radius r, I need to subtract pi r square from it, and I need to add this area, so I'll add 2 pi r square in it, okay. So what is exactly the plan to solve this question? 5 faces plus this one face, so 6 faces we need to calculate. Then I have to subtract 1 pi r square and add 2 pi r square, so effectively I am adding 1 pi r square in it. So this will be my answer for this question. Now just let us plug the data in it. Hemisphere has the diameter 4.2 centimeter and this has got edge 5 centimeter. So if this is diameter 4.2, then r will be 2.1 centimeter. So 6 faces are of 5 square area each, right? What is the edge length of the edge? 5 centimeter. So each face has the area 5 squared and you have 6 such faces. So 6 into 5 square is the area of the surface area of the cube. Then you add 22 by 7 r square. What is r? 2.1. So into 2.1 and the unit will be centimeter square. So this is the total surface area of the new solid. So this is 25. 25 into 6 is 150 plus this will give you 0.3. So this is 22 into, this is 63, so 0.63, right? So 63 into 22, 126, 126. So it will give you 150 plus 1386 and then decimal will come here. So this is equal to 163.86 centimeter square, right? So this is the area of the given solid. Okay, then there is another solid shape here. This is a bird bath for his garden in the shape of cylinder with a hemispherical depression to contain water, right? This hemispherical depression will contain water. The height of cylinder is 1.45 meter. So there is a cylinder of height 1.45 meter, right, and this radius is given as 30 centimeter, right. This radius will act as the radius of the hemispherical portion also and cylinder also. So we need to find total surface area of the bird bath. So what will be the total surface area? 1, the curved surface area of this cylindrical portion, and this area inside this container, right, which is hemispherical. So what is this area? This is 2 pi radius into height. So if I consider radius as r and height as h, so this is 2 pi rh plus what will be this area inside this container? This is 2 pi r square. So r is radius. So I just need to put data in it and I'll find the answer. So total area is 2 pi rh. So 2 into 22 by 7 into r. R is 30 centimeter. So if you want to convert it into meters, or otherwise you can convert this into centimeters. So this is 145 centimeter, right. So the answer will be in centimeter square. 2 pi r square. Where is r? R is 30. So 30 squared. Okay. This area was 2 pi rh. So we need to multiply 145 in it. So this is 2 into 22 by 7 into 30 into 145 plus 2 into 22 by 7 into 900. So for the sake of calculation, we can take 2 into 22 by 7 outside. So this is 44 by 7, and here in this is 4350 plus this has been taken outside, so 900 inside. So this is equal to 44 by 7 into 5250. Okay. Now if you want to further calculate it, you can convert it into decimal form also, right, and this will be in centimeter square. If you want to convert it into meter square, you will have to divide it by 10,000. Okay. So let me calculate it. This was an easier calculation because it will be completely divided by 7. So 750 into 44. 750 into 44. 75 double is 300. 75's double is 150. So its 4 time is 300, right? So this will be 3000 into 3000. So this is equal to 33000 centimeter square, or if you want to convert it into meter square, you will write 3.3 meter square. Okay. So this was about this introduction of this exercise. In the next lecture, we will cover the questions from the exercise, right. I hope the introduction is clear and you have got the clear idea how we will proceed in this exercise. Thank you.